Well, welcome back, everyone, to July's protocol meeting. Today, we're going to be talking about IBC, inter-blockchain communication integration, and also BLS as an add-on as well. And we have several hosts or panelists along with us. Maybe we want to do a quick introduction. Start with
Kiro.
Hi guys. I'm working in Aurora, working as a Rainbow Bridge team lead. So today I will be having some discussions with guys on BLS signatures and actually its introduction as a near host functions and why we actually need it.
Awesome, thank you. Sun?
Sorry guys, had an issue with my app.
No problem.
But yeah, I'm the bridging lead at Composable Finance, and we're currently working on a trustless IBC bridge to near that involves the use of on-chain line clients. And we will also touch on some like host functions and some other protocol changes that we think near should adopt to make this IBC bridge a reality.
Awesome. Thanks so much. George?
Hey, everyone. My name is George. I recently joined Pagoda, and I'm part of the protocol team. I'm working with Bowen. For the past month, I've been focusing on stakers, and I'd like to talk a bit about it today.
Awesome. Yeah, super exciting stuff. And Marcelo?
Hi everyone, Marcelo here from Aurora Labs as well, working as a protocol team investigating a little bit about how we can enhance Aurora. And today I will be supporting, I will be here supporting Kale mostly on the discussion about the merge and how we can help from the near side to make the bridge working after the merge happens.
Cool. Awesome. Well, yeah, Bowen, you want to take away, give a update and move forward from there?
Overview of the agenda. First, talk about some protocol updates as usual, and then George would give us a presentation on Stakehorse, what it is and what we're going to do there. And then we'll have discussions for adding different precompiles for IBC and then also BLS. I think they're not obviously not entirely the same, but a lot of the things there are similar because they're all for the for some bridge, whether it's to Ethereum or to other chains. Let's get started.
Awesome. And yeah, just want to throw out there at any time, if you have questions, please feel free to write them down as you have them. We'll either get to them during the call or we'll save it for the Q&A portion at the end, depending upon how relevant it is. So yeah, at the bottom, there's a Q&A button. Go ahead and click that and ask a question at any time. So yeah, go ahead.
Okay, so yeah, just a quick update on the next release. The 1.28.0 release is going to mainnet in about 2 weeks. And one exciting feature is that the Outbeam 128 precompile is now fully stabilized. It's already on testnet, and if people want to try it out, feel free to do that. So this would enable us to build various exciting things, including private transactions and also other zero-knowledge proofs and so on. And then on the kind of more client side, we had a big refactoring of the client actor to avoid have the trunk processing actually block the entire client actor, which was the case before. And this hopefully would give us more stability as well as some performance gains. And then obviously we're working on the phase 1 of sharding launch. The engineering, a lot of the engineering work has already been done. We're basically in the phase of finalizing that work, and we expect that release to go to testnet in mid-August, and then the final release would be done on mainnet close to the end of September. So that's kind of the very high level updates. And I think George will talk more about stake horse and how that relates to the sharding launch as well. I already saw some questions.
Oh no, they were just asking if this will be
okay.
on YouTube or
Okay,
it'll
cool.
be uploaded.
Okay, cool.
Yep.
Yeah, so that's the quick update on my side. So now I'll just hand it over to George to present on stake horse.
Hey, thanks, Bowen, for continuing the screen share. It's a bit easier like that. So for those of you that have been around the community for a while, you've seen stake horse in the past. You've seen it at moments when the protocol went through a number of changes, and it was mainly focused at the community and helping the community go through that change. We have a similar thinking right now as well. Bowen mentioned that in September, we're planning to release the phase 1 of sharding, and that's going to introduce a new type of validator. It's called chunk-only producer. Definitely, this is going to be a protocol upgrade and will introduce a number of changes. One of the most important ones is the fact that we're going to increase the number of validator seats from 100 to more than 300. Now, exactly how much more we're going to see depending on the data points we get from now until September to see how the network behaves as we approach those limits. But that's the target that we have in mind. Now, with this change going to happen soon, what we have planned is to run a program, and you brand it as stake horse because it follows the same lines of thinking from the past. A program that spans for 2 months. It started yesterday and is going to continue until the 9th of September. And that has 3 main goals, which is to help the community become familiar with the chunk-only producer and give the chance for the community to get an early access to it. Before testnet, we have prepared a dedicated network specifically built for the chunk-only producer. It's called Shardnet. And that's going to be the playground where you can get an early view of what the chunk-only producer means. Also, stake horse wants to create the environment, which I just mentioned, to battle test the code and iron out any sharp edges that we have or anything that still needs a bit of our attention to gain confidence in the release that we're going to have in September. So this is going to help us, the whole program is going to help us from this dimension, iterate pretty quickly through a number of fixes that address any pain points or any issues that the community finds. And the third dimension, which is a very, very important one, even though I placed it last, I placed it there to be able to talk a bit more about it, is assistance to the people who want to become a validator in mainnet. I've mentioned that introducing the chunk-only producer will increase the number of seats from 100 to more than 300. And we wanted to offer support and to help people who want to get one of those seats. Stake horse is there to help with that. You can visit near.org/stake horse to get more information around the program and get all the details around how to join it. Until then, the stake horse is we say it as a community-driven initiative. We've partnered with Metapool, with Linear, with Everstake, and OpenShards Alliance to put this program together and to make sure we have the right set of challenges of technical content for the community, and also to have the right amount of support for the participants who want to join. I've mentioned the dates already. What I didn't mention, and I want to detail a bit now, is what actually stake horse is and how it's structured. We designed it as a sort of a competition where participants receive challenges, technical challenges that they go through, and this is the gamification of the learning process. As they progress through those challenges, they get knowledge and they get skills around what it means to be a validator, to run a node, to run it with very good operational excellence, to have monitoring, to have everything in place so that you can be a reliable community member. These challenges are designed to help you with that, to give you something specific that you can play with, that you can experiment with, and also to give you, as the community is going to be around the program, to give you the support when things don't work as you expected. And as a newcomer in the community, you might hit some issues. But to make it appealing, we allocated quite a bit of a budget to reward the participants that complete the challenges. So we have a total of 4.5 million NEAR tokens that are planned to be delegated to the participants, the ones that complete the challenges at mainnet, and also $250,000 in NEAR tokens that are going to be direct grants for bonuses or special challenges that are going to be part of this program. That kind of summarizes it. I think I've covered a lot of our thinking around this program. As I said, it started yesterday and is going to continue until September 9, and it's going to be the best opportunity that you can have, at least in the upcoming period, to get a validator seat in mainnet, both from a technical perspective and from the perspective of the economical support that you unlock by solving the challenges of the Stake Wars program.
There was one question someone had. Would chunk-only producer data be available on Explorer under Shardnet?
It should be available there.
Okay.
Just to clarify, it will be available, but there will be nothing specific to chunk-only producer. Basically, it will show up as regular validator. The Explorer team is going through a redesign of the Explorer, and I think they may add a separation between different type of validators later on.
Cool. I think that's the only one that we have for right now. But yeah, if you have any more questions, please drop them in the Q&A box below, and we'll get to them after the call.
Thank you, everyone.
Josh, can you also add Blast?
Yeah, I see that. I'm going to add them right now. Hey
so
there.
Is there any action item for me right now?
No.
I don't believe so.
Okay, got it. Thanks.
Okay, so yeah, I think we can transition to talk about adding precompiles for potentially integrating IBC on NEAR. And yeah, so we have folks from Composable Finance joining us today to talk about this work. They are the ones who submitted the proposal and are doing the implementation work. So yeah, I just want to invite both Sean and Blaz to talk about their work. Yeah, feel free to do. I'll stop my screen share so that if you guys want to share anything, feel free to do that.
Yeah, sure thing. Yeah, so I just wanted to say that the components for our bridge from, if you think of our parachain, which lives on Polkadot, to the NEAR blockchain, will consist of, first off, a NEAR-like client that is able to follow the consensus of the NEAR blockchain. Then, of course, a relay that sits in between and is not a trusted entity, but instead relays state proofs, finality proofs of both chains to each other. And then the third component is a set of contracts that live on NEAR that basically are able to understand the IBC protocol and will essentially be how we submit proofs of our parachain data as well as messages coming from our parachain to NEAR. So we have Blast, who's actually leading that work, and he wrote a set of improvement proposals to this effect, set of host functions that will enable signature verification of the Polkadot authority set, as well as the Tendermint authority sets in the case where NEAR can also be directly bridged to the Cosmos ecosystem. So I'll let Blast take over and discuss the NEP.
Yes. So we have introduced the first NEP that is 364 that is kind of bound to signature verification, but we also need another component that we will introduce afterwards that is mostly related to certain hashing algorithms and a data structure that also we would like to see whether we can process that on chain or not. That is also a key part of the IBC framework. And essentially, so far, what we have presented and kind of drafted an implementation as well is 2/3, because I found that the third one is ECDSA. It's already present as with another name, so I just put like a comment that's a bit like I'm unsure whether we should pursue that one or not. But there are like two signature algorithms that we would like to have present as whole functions, because given the validator set size that we have and that might grow into, we are not sure we can process all the computations on one transaction. And we made different tests and adding this with native code, as it was also suggested, comparing different alternatives, compiling how it is done within the WASM code and how it is introduced as a host functions. We were seeing that we were actually like being able to kind of manage the amount of computation that we need if they are introduced as host functions. So that's the main reason for which we're asking for this change. And yes, and so far we've gotten, interesting comments from you guys. We're trying to address everything. There's a bit of a part where some cryptographer on your side was mentioning a potential issue that we would also like to support and understand how to work around this. But yeah, we'll be happy to support on this as much as you need and see if we can get this done.
Mm-hmm. Yeah, so I guess a couple of questions. Basically, you mentioned 3 types of signature verification function, right? ED2519, SR2519, and ECDSA. So could you maybe talk a bit about why you need all 3 of them?
Yes. So we're trying to bridge from Polkadot into Near, and Polkadot in that way is quite agnostic in certain ways. It's like quite open, allowing different accounts having different type of keys, and so this is what Polkadot allows, the type of signatures that you can have if you're coming from Polkadot. So whenever we need to verify that certain signatures are correct or not, we need to be able to support these 3 schemes.
Oh, interesting. So even for validator signatures, it allows 3 different type of signatures.
Yes.
Oh, okay. That's news to me. I see. But I'm imagining in practice, it's not like are all 3 of them used in practice?
So maybe you can.
So the thing is, so the Polkadot authorities are going to be signing ECDSA signatures, specifically SCCP K25 variant. But then, like I said, we also want to bridge to the Near blockchain directly from the Cosmos blockchains or the Cosmos ecosystem directly from Near. And the people over in that side of the camp actually use ED25519 interchangeably with SR25519.
Okay. I see. So if my understanding is correct, for Polkadot we only need ECDSA.
Yes.
And that's actually already supported, right? I think actually Marcelo and Kiro might know this better. They use that more often than other people.
I
don't think it is actually.
It is called I think it's called ED recover or something like this, and I think it is kind of behind the feature flag. I was not entirely sure, so that's why I just put it there and with a comment on if it is already done there and we can use it, then I'm happy. But I was not 100% sure.
ECDSA, as far as I know, it's enabled. It was enabled as a Meth API extension, I think like approximately 1 year ago. And yeah, like the signature of the function, it should be like ET recover. Yeah, the name of it.
Basically, it influenced the Ethereum EC recover, I believe, and if the Polkadot is using the same signature, then sync should work the same way.
Right.
So however, I think that Edwards curve is not available as a near precompile, right? Even though it's validator signature.
Right. Yeah.
Yeah, I was just gonna add that Polkadot is also going to be switching to BLS soon, but it's going to be threshold BLS.
Okay.
We might need to revisit the BLS API later on in the future, but also commenting on all the other stuff we need. I think this one is also pretty useful, but it's the support for what are called child tries. So I understand that the contracts already have, their storage as part of the global state try. We're imagining a situation where a contract might need to maintain an on-chain try that is not itself part of the global try, but instead only the root hash of that try can be included as part of the global state try. So this is useful for IBC, where we have to set certain messages under specific key paths in a try structure, just so that we can commit to the root hash of this try. We can run, verifications, try path verifications on whether some keys are present, signifying that some messages were committed, or whether some keys were not present, signifying that there's a timeout can be fired for the counterparty chain. So I'm open to also like visually sketching this out if need be, but I just want to get your thoughts on this initially.
I think the Rainbow Bridge uses like a similar construction, right? I think maybe Kiro or Marcelo can talk more about that.
Yeah, this actually depends. If we talk about BLS signatures, what exactly BLS curve are you talking about? For Polkadot, I did not track which one are they going to use. So far for the bridge, we need BLS 12.381 curve, which will be used by Ethereum on the merge on the consensus chain, like for the validators.
Oh, so, sorry, Kiro. I think I was more talking about maintaining like a try as part of the smart contract.
Okay, get it.
I think the Rainbow Bridge uses like a similar construction, right?
Yeah, kind of. If we talk about lifelines, the thing that guys are discussing, this is quite similar to what we are currently for.
Yeah, I see. So like, how does how does that work for the Rainbow Bridge?
Marcel, do you want to weigh in? Because you were discussing a lot about this try optimizations.
Yeah, sure. My internet is not great, but hopefully it will work. So right now on the Rainbow, we're using for two things, but we are not representing a try directly on chain. We are only keeping the root for state Michael Patricio tree, and we have tree also built on top of dark nodes. This is useful for making proofs on the proof of work algorithm on Ethereum, but I think this is not completely useful for what you want to achieve for IBC, if I understand correctly. Is that correct, Blas?
Yeah, I don't think it is. So like I said, we want to maintain a try on chain. And we could actually do this currently just using the plain smart contract storage to store all the different try nodes. But then in that case, we'll be maintaining a try on top of a try, which just kills every performance gain to be had there. Which is why we're pushing for this idea of a child try that is basically isolated from the main try, but the root hash is still committed in the main try.
And can you explain the motivation of why do you need to maintain this try?
Well, this is actually as part of the IBC specification for IBC commitment. So as you can imagine, IBC being a messaging protocol, all it really defines is you should commit to messages using this special try, giving these custom try paths, just so that a counterparty chain can easily verify what messages have been committed to your chain. By looking out for the specific try paths. And I can put the link for the ICS 23 spec in the chat if it's very good, because I think it's useful reading.
Yeah, please post the link. But here is a suggestion. I might be wrong. I might not have all the details, but it's a possibility that you don't need to have the whole try on chain. If I guess correctly, the reason you need the whole try is because you need to build the proofs. But for the actual contract, you only need to make proofs, and to validate a proof, you only need the root. So for building the proofs, I think you can use some sort of archival node or some sort of off-chain data that will help you. Like, you don't need to build proofs on chain and validate.
It's not that we need to build proofs on chain. It's that we need to. How do I put this? The try itself cannot be off chain. Okay. If that makes sense. It needs to be on chain.
So I think Marcelo, the problem is that they have like those IBC message that need to be committed on chain, and the try is basically built on top of that. I haven't looked into the details, but that seems to be the case.
Yeah, I got it. My question is if we actually need to have all the data on chain or not. But I will review IBC.
I can also share my screen showing you how we have implemented this on our parachain, because our parachain is also blockchain. And we've basically implemented this ICS 23 commitment scheme on chain using Substrate's child try structures, which are isolated from the main try. And they still give us the ability to basically commit the root hash of that try back to our main try. Maybe you guys can give me permissions to share my screen.
Oh, hang on. Let me see what I can do. Okay, try it now.
So let me know if you can see my screen.
We don't see anything yet.
Huh. It says it's running.
I can't see either.
Okay.
Okay, I should try again then. So let me know if you can see my screen now.
No, I don't. I don't know. Anybody else seeing anything? I'm not.
No.
Maybe try hopping off and back on the call again.
Or maybe I can share the.
Okay.
If it's a link, or I mean, if it's something only on your laptop, then yeah, obviously you won't be able to do that. If it's some link, I can maybe share.
Yeah, give me a sec. I will try to join in on my laptop.
Okay. Okay. Cool. We have a couple of questions. Maybe we could answer real quick.
Sure.
Someone's just asking. So basically, IBC will allow us to bridge to Polkadot. Is that correct?
I mean, you can bridge to Polkadot without IBC, but we just believe that IBC enables for a more robust messaging protocol in general. Plus, it's already in production across the Cosmos ecosystem, and it has proven to be very secure.
Awesome. Is there a GitHub for IBC/Near project or the integration?
Well, we have a light client implementation for Near that we've already put together. Our Blast will put the link in the chat. We've not commenced to work on the contract yet because, as you can see, we're still in the process of researching what host functions we need to make this IBC contract feasible. But yeah, I think for now, all we have is the light client.
Okay. And then are you actually building a Near Cosmos zone?
I'm not really sure what that means.
Matthias, if you have a follow-up to explain that a little bit more, that would be great. And then for a message coming from a parachain, how many signatures will be needed to verify? Well, how many signatures will need to be verified in a BLS aggregate?
In a BLS signature will just be one signature representing some threshold of the relay chain validator set. But currently the BLS is not live yet, so we're still using ECDSA. And what that really means is
recording in progress.
Yeah, sorry about that.
That's okay.
Maybe you can make my laptop the part of the panel so I can swap out of my iPad.
Yeah, no problem. Let me see where which I don't see.
So my hands
raised. Oh, your hands raised. Ah, I see. Yeah, that's why you weren't in alphabetical order. All right, now you're a panelist. And
all right, so
now I'm gonna allow you to share your screen.
So yeah, I was saying I didn't understand the question.
Yeah, that was from an anonymous person. So yeah, if you, well, maybe this is a follow-up. They're building a light client for substrate chains that can keep, oh, this is something different.
All right, so let me know if you can see my screen.
Yep, we can see it. Perfect.
So this is one of the key paths for the IBC commitment try. It says that whenever you get back acknowledgements, and acknowledgements are basically like, if you think of the TCP protocol, you send a message, you get back an acknowledgement saying that this message from the counterparty chain, letting you know that your message was successfully delivered. And so that has to be stored on chain, as you can see under this custom path in the try. As you can see, so we use the substrate child tree implementation, which allows us to do this fancy stuff. And what that allows us to do is, at the end of the day, once all the IBC messages have been processed and the try has been mutated, we can just simply call a function to say, hey, give me the child root hash of this try. And then we can now persist this in our header as part of like a consensus message, so we can get like signature finality proofs for this IBC root hash. So what that means is, for instance, with this acknowledgement that we've stored on chain, the counterparty chain can know that, oh, we've actually received the acknowledgement, and they cannot time out, for instance, messages that are sent to our chain. And there's other stuff in here. With not just acknowledgements, we have to store channels, open channels, just so that the counterparty chain knows what channels are open to them. We have to store client states. And if you are familiar with light client development, you know that this is the minimal state that a light client needs to verify incoming headers from a counterparty chain. We also need to store connections, which are the lower level, which channels are built on top of. And maybe I can even open up the IBC spec just so that I can give a brief walkthrough for 24. Right, so this is the host requirements. Says that you must have a provable store on chain. And it defines the paths. These are all the paths. These are part of the IBC standard. And just to scroll a bit, to see what else they say. Well, I guess that's basically it, but this is just a general idea of ICS-23. You have a try on chain that maintains these key paths and stores these pieces of data, just so that we can be sure that like these are the events happening on chain. So, any questions?
Yeah, I got the idea from here. So yeah, having a try on chain makes perfect sense. I still will go with this documentation and make sure that this is the best we can do. Because if we can do something better than that, let's strive to do that. Yeah.
Just one thought, like the construction of the try doesn't have to be done on chain, right? Or is that somehow dictated by the IBC protocol?
When you say the construction of the try, I don't think that you have to construct the try on chain. I think that you can construct the try off chain, but from the context of IBC, that try must act like a key value store, where you can set some key paths with some values, and you can. But then at the end of the day, we're able to get the root hash of this try.
Right. So if I understand the requirement correctly, you just need to be able to get the root hash and also provide queries to certain key paths, right?
Yeah.
But that doesn't. Yeah, but that doesn't mean that you need to do all the computation on chain, right? I believe that one of the reasons why you're running into, for example, the smart contract constraint is like you're trying to do all the computation on chain, like doing all the hashing and all that stuff, which it doesn't seem to me like that's completely necessary.
Okay, maybe you can expatiate a bit more.
Oh, yeah, I mean, obviously I don't have the full picture, but you know, similar to what Marcelo mentioned before, like you can, for example, take some of the computation off chain, and then you can put the result of the computation on chain, and then people can verify that the computation is indeed done correctly, and if not, maybe there's a way to submit some kind of a challenge that to show that this computation is not done correctly. Like you have all the underlying data on chain, like people can easily verify that the computation you've done indeed is correct.
Right. So just to be clear, in this case, the computation we're referring to is basically how this off-chain IBC try is being mutated.
Yep.
So you're suggesting we build some sort of optimistic system on top of that?
Yeah, kind of.
I see. That is way out of our current team possibilities at the moment.
Okay, but I mean, to be honest, I feel like that's an easier way to do this, right? Like but I mean, well, first of all, like I'm not sure whether we would be able to introduce all the host functions you want, and even if that's the case, it sounds like you need you want to do something even more than that, and I mean, you just compare the implementation complexity, and I'm not sure that's actually better, like an easier approach.
Yeah, no, I get that it's definitely not going to be easy to add support for some sort of child try to the near blockchain, but this stuff is not just going to be useful for IBC alone. I think it's because we've not yet seen a lot of developer usage on near, but as people start to come up with like very complex stuff, they will need more complex APIs. And having an on-chain try, like if Substrate didn't have this on-chain try, we would not be able to implement IBC for our parachain. And so I think the same thing goes for Near as well. Like if you want to do complex stuff, you're going to have to provide the necessary developer tooling for this.
I mean, I do agree with the last sentence you said, but at the same time, I feel like it doesn't necessarily imply that you have to provide all the kind of abstraction out there. Like I think I still need to understand better, like what like why exactly you need this thing to be done outside of the main try. Like our developer model is that from a smart contract point of view, like it's basically operating on like a key value store. Like it doesn't really care how exactly the underlying content is stored. Like it from the smart contract point of view, it is basically just interacting with like a key value store. Like you have the storage read and write API to do that, and it doesn't really, and it shouldn't actually care about how things are stored underneath. Because, for example, what if we change the try implementation in the future? Like today, it is basically a Merkle particular try, but doesn't mean that we cannot change the underlying try, how the state is represented in the future, and have kind of have the smart contract operate on like a different abstraction level allows us to do things like that.
Yeah. I was going to say that. I've forgotten what I was going to say. I mean, the reasoning behind trying to have a try is just so that we can, like I said, not abstract a try on top of a try. I remember, if you remember, we were on this call yesterday, it was 2 days ago, and I asked you if we are able to get the contract storage root, and you said that that's impossible, unfortunately. Otherwise, the contract key value store would have been perfect for this. But the fact that we're not able to get the contract storage roots just makes it impractical for us to use it for this try implementation. And then, like I said, the only other alternative is to actually just use the contracts key store to maintain a virtual try, which of course will store more intermediate nodes and everything, which is not really efficient, as like I said in the beginning.
Mm-hmm. I see. Well, in that case, it might be an easier approach to add support for the contract state root hash into the account. Then providing like some kind of separate abstraction, because you need to think about if you want to allow the account to maintain like separate try, well, that would be a lot of work. That needs to change how the entire state works. And I'm not sure whether that would be well, to make a big change like that, obviously needs not only just a lot more work, but actually a lot more people looking at it, making sure that it doesn't accidentally break other things, and it actually makes sense for Near as a whole.
All right, I agree. If we're able to get the contract storage root, then we might not need to maintain an external try.
Mm-hmm. Okay. Yeah, I think we're running short on time. I do want to just still give some time to discussing this BLS proposal, or probably not proposal at this point, but this idea. So yeah, I guess Kirill, could you talk a bit about the necessity of supporting BLS in the context of the upcoming merge?
Yeah, sure. Let me fastly describe what's exactly needed for the merge and for the Rainbow Bridge. I'll do it shortly because we are quite out of time. Basically Rainbow Bridge, how it works, we use light clients on both of the sides. So currently, light client for Ethereum is a light client on Near, which makes like proof of work check. And this is the thing that Marcelo described, where we have all these DAG nodes, with the help of this, we can actually verify proof of work. And on the other side, we have a light client for near on Ethereum side, where we optimistically verify signatures of near validators. With the merge, this thing is required to be changed, and we are currently working on this implementation of the light clients of Ethereum with the merge. So if I shortly describe how it will work, so it will work in the following way. Now we are going to maintain both execution, which is the same block as we currently have on Ethereum, and consensus chain. And consensus chain will consist of beacon blocks. So for beacon blocks on Ethereum, they have like a set of committee, which are like 512 validators that are assigning the messages for the blocks, like for final blocks. So we expect to utilize the same thing, and like the idea will be that we will be submitting the blocks, and then we will be verifying all the internal data, its inclusion of execution block within the beacon block. But also we are going to verify the signatures of this committee. And this committee is using BLS signatures with BLS 12.381 curve. And in this case, we are talking about the verification of up to 512 signatures, but this could be aggregated due to the nature of the BLS signature. So we actually need to verify an aggregated signature of n validators, and could be like from 2/3 up to 512, regarding on who is voted and who's not. And because of that, we actually need to have a support of BLS signatures. So far, we have been working a lot on the implementation of BLS signatures as near WebAssembly contracts, because we expect that the merge most likely will happen before we have BLS signatures available as a near post function. So far, we have been trying with two libraries, which seems to be like most promising. One of them is supranational BLAST. This is so far seems to be like one of the robust libraries that we have on Rust. Basically, the library is implemented in C, and it has Rust bindings. And the second library is Malacro BLS, which is implemented in pure Rust. And the BLAST, the first one seems to be like more robust because it actually has like a couple of audits and a couple of more cryptographic audits are ongoing. So this is a good sign. Also, both of these two libraries, they are being used by one of the official consensus client reference implementations. It's called Lighthouse. It's being developed by Sigma Prime with the support of Ethereum Foundation. So yeah, this is exactly why the choice we are like striving out of these two libraries. But for example, we were able to successfully compile my library BLS as a near WebAssembly contracts recently. Unfortunately, our first tests show that we are not able to verify the aggregated signature because we are actually hitting the 300 Tergas bound, and it seems that we are not close at all because we tried to be able to compute at least part of this verification, let's say like 10th part of it, and we are still hitting these limits. For sure, we expect that these libraries could be optimized in terms of how it works with the memory. So to adjust it more like with a near execution runtime and maybe optimize it a little bit. But in general, it shows that it's definitely a huge amount of space for optimization if we have this available as a near cost function. So we will be working on this solution too, because actually without this BLS signature verification, that means that we need to use some kind of other thing, like either trusted mode to submit blocks or some kind of multisig or whatever. This is still to be discussed. Yeah, in general, the thing like this, And if we talk about this BLS signature support, we are basically talking about multiple things. So first of all, I would say that we also need to have, perhaps near community will appreciate if we have like a general support of BLS 12381 signatures. And then it also makes sense to actually expose the BLS signature verification interface soon, because the difference here, if we talk about, for example, this library, which is supranational BLAST, which is implemented in C, if we just implement curves as a near host function, that actually needs that all the client libraries that are related to the BLS signature on top of BLS curve, it will be needed to be modified with using near host functions. And this, I think, will be quite limited if we talk about that C library with Rust bindings. But if we do both of the things, so both BLS curve and BLS signature verification, that could be like quite useful. And in this case, as I see, I was not aware of this. It's gonna be useful for IBC bridge with Polkadot, as guys mentioned that they are going to migrate to BLS signatures. For the thing of generalization of what kind of behavior is required for BLS curve, we can actually utilize the existing AP, which is the AP 2537. So this is an AP was proposed by Ethereum community because these BLS signatures, they will be part of the consensus layer, but they are not yet available on the execution layer as a precompile. However, this AP was already implemented in Go Ethereum. It was just not applied yet. So yeah, in general, like this, as we have like 3 minutes left, guys, please give your questions. And also, I think that as we are going to work on this NAP with this availability as a near host functions, as it's also useful for the thing that Sean and Blas are working on, we would really appreciate your efforts on this discussion and supporting us on this too.
Yeah, so Kirill, like a question is like you mentioned that you're going to maintain both the beacon chain and the execution chain on the light client. How does that actually work? Like, is it possible to only maintain like some kind the beacon chain as light client and somehow submit like 2 set of proofs similar to what you do on the Ethereum side for near?
I didn't clearly get your question. Do you mean why we cannot use the same model as we do with the near blockchain?
Oh no, I'm more talking about how the light client for Ethereum is maintained on near. It seems like you mentioned you're going to maintain both the beacon chain and the execution chain.
Yeah, so basically in this case we need to maintain beacon chain because obviously the validators, so they will sign the beacon chain, and in this case we are not technically will be submitting the execution chain also on top of this, but the thing how it works is that we are going to submit beacon blocks, but inside beacon blocks we have a beacon block body root and everything there like is a trees. It's a tree, and then the beacon block body root, it contains a hash of the execution block. So we are going to build a proof that this is actually this execution block is being included in the beacon block.
I see. Yeah. So it's basically similar to how the light client on Ethereum for near actually works. You have like a kind of 2 set of proofs.
Kind of, yeah, but still a little bit different. On near, the good thing that we can easily use this optimistic model that we are currently using, because we can reject and challenge in chain if one of the signatures does not match. In this case, this doesn't work for us because we actually need to verify the aggregated signature.
Oh yeah, I understand. Yeah. Okay, sounds good. I think we are running out of time, so thanks everyone for the participation. And it looks like there's no outstanding questions at this moment.
Yeah, I think we're good. Thanks everyone for joining, and yeah, we'll see y'all next month.
Yeah, see you. Bye.